Welcome to Networking Field Day. The presentation that you are about to watch from Barefoot Networks is being attended by a group of invited networking delegates who represent the community by asking questions, offering opinions, and discussing the technology that you are about to see. If you would like to see more information about this event, please go to our website, techfieldday.com, and check out our YouTube channel, youtube.com/techfieldday.
My name's Ed Doe. I'm the VP of Product and Business here at Barefoot. Like many of our founders here at the company, I also joined from the 10,000-pound merchant gorilla. Broadcom spent many years there working on switching chips, so a lot of experience in the market. So we've got a really good cross section of people from many different sides of things. What I'm going to talk to you about today is how do you actually get your hands on the Barefoot technology, whether that's Tofino, the P4 programs, everything else. And I think we've touched upon it a little bit as we walk through the day, but wanted to give you some more specific examples and how do you go about extending that. So how will network engineers and admins actually take advantage of Tofino, Capilano, and P4? The first that we've talked about is there's many OEM platforms from your favorite vendors that are going to be working with and have already taken and gotten their hands on Tofino and the P4 programs and writing a lot of those things. That means that they have their own switch, whatever your favorite switch OS that they've put on multiple different platforms. They build their own boxes, and then they write their own P4 programs, or they start from switch.p4 and extend it, add all their own things. Nice thing is that they get to hold on to whatever they write in P4, just like Intel doesn't get access to every C program that's ever written on their processors. They get to take that and they get to innovate at their own speed and offer those solutions to the market. And then they leverage the Barefoot Tofino chip in all of the different form factors from 6.5 down to 1.9.
So just to clarify something there, because I'm curious, so outside of the switch we see here, are you saying that we'll see the Tofino chip in other switch manufacturers? So it's kind of a white box, approach in a sense.
Well, so
you guys are kind of beyond, you're the next level of white box really with what you're doing, but that's what I was curious about. Is
I think as Nick kind of talked about earlier, is you're actually going to see OEMs present this to market in their own way, shape, or form. The difference is, they'll present it as a regular box, right? Pick your favorite vendor, they'll offer it to you as a regular box. The difference is, now think about the next step. Say VXLAN GPE comes across, comes along down the pike, or some new protocol like Geneve, or some extension to MPLS, or some new form of telemetry. The big difference here is the OEMs will not have to say, oh, you're going to have to buy this new box. Hey, well, I just bought this box, that does this, 2 years ago. And now there's new protocol that pretty much obsoletes everything that I have. The difference is the model is that they're going to be like, great, let me ship you a new version of my Switch OS, which has a new P4 program embedded in it on that same piece of hardware. And now, voila, instantly upgraded, either hitlessly or in under 50 milliseconds. And now you have this new feature available to you. And so that's the dynamism that you're going to be able to get with the OEMs. The OEMs, it's up to them. Do they want to open it up and expose it and allow the average end user to write P4? That's really fundamentally up to them. Or do they want to say, hey, the average enterprise end user isn't going to be writing a P4 program and adding that functionality.
So do you guys see a world where that, if you have the Switch OS that's an OEM Switch OS, do you see a world where that Switch OS will eventually become more independent, like some other things that we're seeing?
So it's a good question. I mean, clearly there's these disaggregated platforms that everybody knows about, the white box world, where you have disaggregated OSs or third-party OSs that run on white box hardware or ODM hardware, and they'll be able to leverage open source everything. The question is there some hybrid in here?
Yeah.
Potentially, right? And I think that's fundamentally up to the different vendors to come out with those models for people, and for people, the end users, the average network engineer, to start to create that pull and demand and say, hey, I like everything you have right there. Maybe I want to add on, this extra feature. Give me access to the P4 program that's running on your platform so that I can go extend it in the way that I want to go do that. And so really you think of, the potential for, it's like hybrid, hybrid disaggregated, with OEM,
platform. There's a lot of possibilities there. It's very cool.
And I mean, you already see many more OEM OSs open up, right? The OSs have already started to be, you can add your modules. So think of it as just an extension of that. Let me add on to that OS, and now I have the power of adding something to the data plane.
Sure.
Right. So we've kind of touched on those two models. There's definitely the white box model, a new model that's growing. It hasn't taken over the entire market, hasn't put any of the OEMs out of business, but it's one that is available. And so that's another way that you can get it. And you could very well imagine, this is a new paradigm.
Yeah.
It hasn't existed before. Maybe some OEMs will offer some in between options.
Cool.
And then the last mode that people and the average network engineer will actually get to harness the power of Tofino, Capilano, and P4 is actually not naturally thought of. One is in cloud platforms. So the other customer set for us at Barefoot are the large cloud providers out there that build their own clouds, build their own data centers, they build their own gear, but these are more and more becoming an extension of the core enterprise IT infrastructure. And as Nick has talked about, one of the big challenges is you have this stuff that's off-prem, you don't get as much visibility into it, but now with the power of some of these visibility applications, you could think you could actually get as much visibility or more off of a cloud platform that is taking advantage of Tofino and P4 and really be able to manage it and have the visibility and give yourself the assurances and the SLAs that you'll be able to do that as well. So there's actually a few different modes in which people will be exposed to this power and this capabilities that are out there. One thing that we actually announced this week, in fact yesterday, was the announcement of the first white box platforms that were out there. We in fact had from 2 different vendors, 4 different boxes, so you're already seeing them spread across all of the different ones.
Really cool. I'm actually doing an Edgecore deployment the week after I leave here, so that's awesome. Yeah.
Wow. So you see, it's a reality, right? And in fact, the 2 boxes that we have here are the Edgecore boxes. And one step further, we actually kind of merged what the big cloud providers are doing with some of these, where if you notice, these 2 boxes are actually wedge derivatives. If you're familiar with Edgecore, they're the current provider that gives you the wedge box, which is the box that Facebook built and open sourced into OCP. And here you have a wedge 100 that actually shares all of the same internal guts with the original wedge, except it has a Tofino in there. It has the same CPU module, fans, power supplies, OpenBMC, LEDs, console port, and all those different things. And we extended it and worked with Edgecore here to provide a 6.5T. There's no 6 terabit systems out there, and so this is the first 6 terabit system that has actually leveraged something from OCP, and you're starting to see the genesis of all this open hardware lead to more innovation in different platforms. So you have a 3.2 and a 6.5, and then WNC, which is Wistron, the large server manufacturer that supplies a bulk of all the lot of the cloud platforms and servers. They're also building networking hardware, and they have an interesting one, which is a 48 by 25/10 gig with 6 by 100/40 gig uplinks. So you can think of it as a future-proofed 10 gig to the server with 40 gig uplinks, already set to go 25 and 100 whenever you're ready to do that. And there's also the OSW 6500, which is a 6.5 terabit. And so naturally the hardware comes first, then the software will be coming onto these platforms, but it's actually pretty impressive, right? We're using standard process. Last year we announced the company, taped out, started sampling the chips, and here you have immediately available systems, that you can go to the white box systems and go take advantage of that. The other thing that I wanted to tell you about is, how do you get involved with P4? P4 is something that isn't, just a Barefoot creation. It's actually from its original creation was something that was collaborated by many different companies. There's an open source project. Barefoot is one of many different contributors out there. And there's many different things happening in P4.org where many companies are contributing P4 programs. So for example, EVPN that you were just asking about, AT&T, the biggest service provider, here in the US, wrote a EVPN program on P4, 78 lines. Didn't have to forklift anything, just 78 lines to instantiate how they wanted to do cross-connect with EVPN. And they have it with P4, and then they can go add it to whatever platform they want.
Wow. So I'm just curious, is that part of their network function virtualization they've been working on?
They've talked about it at a couple of different conferences, especially the NFV conferences and those, and they talk about it as a way to offer new services to customers to provide better connectivity into their EVPN backbone and a lot of different applications. The beauty of networking is many of these protocols are applicable to lots of different scenarios, right?
Sure.
There's a lot of people contributing to development environments, so you can test and debug your P4 programs, simulate these. People are simulating networks with hundreds of switches, all in software, so that you get to take advantage of that. And there's actually many other P4 targets, ranging from FPGAs to network processors to NICs, smart NICs, there's OVS, smart switches and software right into the kernel and all those kinds of things. So there's actually a very active ecosystem that's out there. The nice thing is that P4 and programming or programmable data planes, even though we're a huge proponent of it, are actually coming to the entire network, end to end, all the way from embedded into your OS, all the way to the far reaches of the network.
You may not ever even use it, but your silicon will have that capability.
Exactly.
You may never even implement a programmable capability. You might always just buy the operating system that the switch gives you and just you do MPLS and blah, 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 whatever it is. But underneath it, that functionality will always be there. In the same way that a lot of people use their Intel CPUs to run Windows 10 and Microsoft Word and never do anything interesting.
Exactly.
But yeah, that's kind of your model, isn't it?
Right. And that's the benefit, is you don't have to be a P4 programmer to enjoy or reap the benefits of this. An OEM can harness those benefits and bring them to you in a much quicker time frame, and actually it might end up being better for you because you don't have to rip and replace network gear. That's very painful, as we all know. Is actually substituting a switch is a very time-consuming task and impacts all the users that are out there. You have to schedule downtime. Now you could just be talking about, here, give me a small maintenance window, 50 milliseconds.
Yep.
May not even be noticed to most people out there.
Yeah, for me, it's about in the IT enterprise, your switch may well, like most enterprises haven't even moved to 10 gig yet. So having a switch that does 10, 25, 50, 100, it's actually viable to start considering about owning that for 10 years. But you wouldn't consider owning a traditional ASIC for 10 years because there are new protocols, new control planes, the CPU's not big enough, the memory. This type of architecture gives you the possibility to actually consider owning the hardware for 10 years, but a software cycle that iterates at a 6-month cadence.
Right, exactly. I mean, that's the developer-led, enterprise where things, new applications are coming up. You don't buy one version or version of a specific application, right? You're getting constant upgrades all the time and being able to update to the latest functionality and features. Nobody buys Office 2013 and never expects a new feature to come with it now, right? Think of it now that model, as people have moved to Office 365, is adapting over time, right?
And the philosophy of needing or having it and not needing it is always better than needing it and not having it. And we've always kind of accepted the second one because it was our lot.
Right.
Now we're getting to a point where if it's not there, make it, and that's good.
Right.
I like it.
Yeah. So, people need to start asking questions, what are going to be the future potential capabilities of my purchase? So we actually talked about one of these. AT&T very publicly, they wrote their program. It was flex_cross connect data path there. It was actually an EVPN implementation, 78 lines of code. The beauty of this, it actually illustrated how quickly the innovation happened. As Nick talked about, is they didn't have to go argue in IETF and ask all the vendors to go do it. They actually wrote it. 78 lines of code, doesn't take that long. They provided it to one of their OEM vendors. Their OEM vendors then went and implemented, and they got a working implementation, in just a matter of a couple weeks. Under a month. I mean, that's amazing just in terms of that iteration, and they were actually able to do a trial. Now, they didn't go to put it in production. They're going to go test it and make sure. But in fact, they had a level of confidence that was significantly higher because, hey, it's code. There's no misunderstanding of what that is. It wasn't like I told you, oh, I wanted to go from this to this, and maybe I didn't misunderstand or come up with all the scenarios. You had a level of specificity that was there. Another interesting scenario was actually Fox's own advanced technology department that actually works on a lot of broadcasting technology. Their Fox Networks engineering and operations team, they actually ended up writing 3 different P4 programs that then they contributed back to the P4 organization, open source them, Apache, so benefit everybody to look at. And they've been looking how do they change their transport over from older switch, digital video, which we're even using in this environment, to get the video off of the laptop, back to the encoder and switch that over to a packet network. And they're needing to do this because bandwidths are going up. 8K is around the horizon, 4K. They want to get more and more 4K video streams. And they said, well, the old way that we switched, was kind of what didn't take into account the video stream. We wanted to be able to do it on a frame boundary, and be able to do that as opposed to a packet boundary or turn off the port and all those kinds of things. And so they need to innovate, and they actually wrote a few different P4 programs to help innovate there. Again, very short programs. You can go take a look at them on p4.org. 10, 20, 40 lines of code. And the nice thing is they can then go add those to existing platforms or ask vendors or OEMs to go supply those to them. And then we have numerous large and medium enterprises that are actually looking at adding things like firewalls, load balancers, or actually doing application-specific routing. How can the network adapt to the application as opposed to the other way around? The application always has to work around the applications there or the network itself. So, going back to this, you're going to see this, right? What is it that you're seeing out there? New protocols. That was FOX, right? Increased network reliability. Get rid of these older protocols. Again, FOX saying traditional IP transport isn't good enough for me. Let's focus on this. You've got flexible tables, so you're able to reallocate over time, and then the greater visibility into the network as well.